Good morning, everyone.
Morning.
Hello.
Hey everyone, Sonny here.
It's only
Thanks, man.
Hello.
Okay, I moved the Excel sheet to Google Sheet, and I shared with everyone who's on the call, except which I need to share it with you.
Oh, that's great. Thank you for that. I just got the email.
Wolfgang, I don't have your email. If you don't mind, send me an email. I will give you access to the Excel sheet.
You mean for the Google Doc? I just give myself Google email.
It doesn't matter. Any email works.
Yeah. I put my Google email in the chat.
Thank you.
Hey, sorry, I'm late.
Hey, Rafi.
Hey, Shahab, I just sent a request, it says I need access, so I just sent you a note.
I added you, Kevin, with your Elian email. Kevin at elian.com. Am I right?
Oh, okay, okay.
Okay. Should we start? We have short.
Hey Shahab, Sonny here. I have a quick question.
Sure.
I saw the list you just sent, the Google Sheet one, and I was looking at the recording because I didn't have access to the previous sheet from the attachment. And it looks like there are some missing rows from the Google Sheet version. I'm not sure if that was intentional or there was a change since that last recording 2 weeks ago?
No, actually, I'm moving those one also there, but slowly, because
Oh, okay.
the top part is a little bit different, but I will add it actually.
Okay, no worries. Just wanted to make sure I'm seeing the correct one. Thank you.
I temporarily added there, but let's see.
Okay. And your voice is a little muffled. I don't know if it's for only me or
No, it's also me, so I think your mic is not quite clear there, Shahab.
Right now I'm gonna fix it. Give me one
there you
second.
go. It is
Perfect,
fixed
yeah.
now.
Okay, good. And I added that part also on top of it. Hopefully it didn't change anything that much.
Okay, thanks.
No, it looks like it messed up everything. Hold on. That's why I didn't want to paste them.
Yeah, that's weird. Google Sheet doesn't allow you to add your Excel sheet directly. You have to,
Exactly.
yeah.
Well, let me see if I can do
Microsoft versus Google. Sorry, it's been recorded.
it. No comment on that. I think I got it. Don't worry about it. I think that this version has everything.
Oh yeah, I see it now.
Okay, good. Let me share my screen and then we can move on. Okay, do you guys see my screen?
Yes, yes.
Okay, I think based on my note, we were all the way up to line item 31. This is 31, this is supposed to be 27. Okay. I think all the discussion happened all the way to 31. We review, should we report IO swing value, peak to peak, or just we say, okay, what's the value of it or not? I think there was a discussion that why do we need that? Yeah, again, history from there, because some of the standards files, they have a different basically IO swing requirement to save power. And we like actually to see how much it is for interrupt. Any comment on that? Should we keep it? Should we drop it? I'm open to it.
So I guess it's been a couple weeks since we did this, but for each of these, there's going to be a some kind of description of the methodology, because it's obviously very frequency dependent. So this is going to be like DC or something. Anyways,
No, this is not
separately define it.
sorry, Kevin. This is not going to be frequency dependent. This is the output swing requirement at the output of transmitter. For example, are you going to be rail to 0.7, 0.9, whatever swing it is, or you're going to reduce supply, which is more advanced PHY these days, 0.3, 0.4, you know, that kind of range.
Okay.
Most of the memory links right now, they are on the reduced swing. Right?
Yep.
If I recall correctly, if they are on the call from D-Matrix, I think D-Matrix developed the bow in two different fashion. Correct me, Bobby, or anybody from Analog X, not Analog X, D-Matrix on the call. They have a standard bow, which is no IO swing, no swing reduction for IO, but they also have that version to save power.
Okay. Anyways, but for each of the technical things, there'll be some definition of it, explanation.
Correct.
maybe
Right now, we just want to see this is a good thing to report or not.
I
Later
think
on,
it
we
is.
will define.
Yes, I think it is.
And the second, another item is going to be on the physical, more on the bump map. Bump map spacing on the X direction, bump map spacing on the Y direction, if it exists.
Yeah, so for me, I think these two lines, I think you're over constrained. Personally, I think it's over constrained the definition that the beachfront area, the X and Y dimension of the macro makes sense. But there's a lot of different staggered designs or non-uniform bump maps. personally, I think I would not include 32 and 33. That's just one vote, though. Other people may not agree.
Any comment from others? I mean, Boppy, Majid, Sunny.
You can have a pitch one, but I don't think you would like to have a X and Y instead, right? Because if I interpret the X and Y, you are trying to say is the age spacings or not, because else we generalize it as a bump pitch. That should be sufficient already.
Some of the standard have different bump pitch for X and Y direction. For example, HPM is one of them.
Well,
Your X dimension is different from Y direction in terms of the bump spacing.
exactly. They all do. Bow and UCIe are basically rotated 90 degrees. So the bump pitch is an interesting metric. But
if you have a X and Y difference, then I guess the typical expectation is that you should just report the worst case scenario. Should be sufficient already.
My point is either we report bump pitch as X and Y, or if we don't report it, because reporting one dimension doesn't give you anything.
Okay.
Reporting one dimension is going to give you only the size of the TX and RX beachfront, which we're going to capture it in 34, 35, 36. This reporting of the bump spacing in the X and Y direction is number one for interop. If somebody is, for example, mapping exactly HPM standards, that's number one. Number two is actually more on the stress from the crosstalk, how much crosstalk you consider during the test of this parameters. For example, if you are saying this is in the 5 nanometer process, and this is the speed that we are getting, with what kind of bump spacing you got that speed?
Yeah, I think I kind of agree with the comment, like having just the pitch information is not sufficient because we're talking about interoperability here.
And the pitch is it used to be basically uniform in X and Y, but recently they are not.
Yeah.
For example, people relax one and then put more stress on the other one. I haven't heard anything from Majid and Boppy and Anshu.
Well, my memory or the reason we were doing this was also to figure out the range of bump pitches for which this would work, right? But I guess now we're doing specific implementations, so each implementation will have an actual bump spacing. But wait, I don't get why you don't want both. I'm kind of lost on. I didn't understand what the hard downside is.
I think it was Kevin comment. I'm okay.
My comment is that people are interested in lines 35 and 36, which is the X and Y dimension of the phi. Total beachfront. I'm not exactly sure. What's the difference between 34 and 35 or 36?
Oh, because you could achieve this in a variety of ways, right? At least with Bow, you could stack differently and still be compatible. I think UCI is much more prescriptive. Choosing one gives you the other.
One is area, Kevin. Basically 34, 35, 36 is talking about the total area and beachfront density. 32, 33 is more on the bump spacing.
Wait a minute. So 35 says X dimension and Y dimension.
Yeah, that's the area.
And it says millimeter. It doesn't say millimeter squared, but it does say the word area. So I'm confused about what they mean then.
Okay, then we will get there. Maybe.
Okay, so my answer on 32 and 33, and unless I don't understand 35 and 36, I think it's over constraining that because bump spacings may not be uniform. They'll certainly be different in different directions, and they may even not be the same from bump to bump or row to row. It just all depends on physical dimension
Oh,
layout.
I see what you're saying. Okay.
And so I think what matters
to
to
get it,
people who
sorry.
are building packages is the minimum pitch and the minimum line width and spacing to escape. And then, you know, the physical, the X and Y dimension of the phi, which the beachfront is independent of how many are stacked. I totally agree with you. So I think the beachfront and the total X dimension size are the same thing in whichever those are. And then the total Y dimension size tells you how far it extends into the ASIC, I think, if I understand X and Y. I usually just call them beachfront and depth because X and Y is confusing.
No, wait.
Yeah.
Kevin, I think this group is for unit. The beachfront for the phi as a whole, this is the unit one. So that brings up a big.
I think we are jumping to 34, 35, 36.
Okay, okay,
I
fine.
may agree that
Anyways,
there-
I explained my answer. Reason we were just highlighting things in yellow that we want to talk about later. So maybe without understanding the rest of them, it's hard to talk about them, but it
Correct.
seemed like it's over constraining it to try to fix the X and Y pitches.
just I want to make one comment, Kevin. Maybe that's actually explain why we have two different things. Some of the phis are not bump limited. For example, look at the LR, long reach SerDes. You cannot fit all the SerDes under one bump, but some of the standard like Bo are bump limited. Therefore, the area it's a little bit different from the bump spacing. In one of the cases like Bo, could be you're right. The spacing of the, for example, number of bumps times pitch is going to give you the area. But for long reach SerDes, for example, it does not. Because the circuit is larger than the bump spacing.
Yeah, so I totally understand that. I was only thinking about dotted I links right now. So
Okay.
sure.
That's why
Okay.
in 32 and 34, we are trying to just capture the bump spacing. Again, my only outcome from 32, 34 is the crosstalk management more than anything in terms of the area and compatibility and interrupt. This is the two takeaway basically from 32 and 33 information.
So to get to Kevin's point, maybe the easier thing that we really care about in 32 and 33 is simply the minimum bump spacing in X and Y in this.
That's what it means. You cannot say.
Well, you think it can be taken to mean average. So we just explicitly say minimum bump spacing X, minimum bump spacing Y.
I think the crosstalk matters, so that's why somehow it should be captured.
Yeah, then we're all in violent agreement.
I add minimum, but Bobby, remember this numbers comes from the implementation.
Right.
It means that there is no two different bump spacing to pick the minimum. This is what they implemented, and this is what we measured. That's
So
no, but Kevin's point is there may be non-uniform bumps. At least that's the way I understood his point.
there are lots of cases of that. So yeah, I would, in any event, I'm fine with what you've written. Maybe we keep going so I can understand what
Okay,
the context is.
so the main difference between what you're saying and what Kevin's saying, the way I understand it is, one implies an average bump space, the other says this is the minimum, but they could be non-uniform.
Agreed. That's what it implies. Okay.
okay. Should I keep it yellow or green?
Well, until you feel good about it, keep it yellow, man.
I'm good with it to say minimum data bump space.
Okay, then we can green it up.
Okay, then the 34, which is maybe kind of redundant with 35 and 36, but let me explain three of them together. The 35 and 36 is talking about the single pair of the TX and RX plus amortized clocking, an area that it's taking, everything together, one TX, one RX, and one clocking that you need to basically put there. The whole area is going to be TX and Y dimension, which we're going to report it as an area X and the X dimension and Y dimension for total area of the one TX RX plus clocking.
So Okay, I'm not sure why you're doing that, but line 34 is the total beachfront, right?
Correct.
For the phi. If it's 16 lanes, it'll be 16 times number 35, I guess. I'm not sure. But but you don't have a Y dimension similar corresponding to number 34?
No, usually when people say beachfront, they don't report basically the Y dimension. We had it as a maximum stacked unit, which is in line 38. That's why I prefer 35, 30.
What does max stacked unit mean?
How many you can actually, how many of this phi you can stack and go inside the ASIC in the Y dimension? Let's assume that.
Hey, Shahab.
Sure.
So I'm thinking that, if somebody's selling they're selling a macro, right? Most people sell a macro. They don't sell like units. So this distinction between the unit and the whole thing made sense when we're evaluating the standard. But if you're buying a phi, you're buying some like bandwidth, right? You're buying like, my understanding is you typically buy like
It's conceivable that someone would sell a phi and let you stack them. I think 99% of the time that's just going to be one because people are going to sell a unit. But where does the Y dimension of the phi appear though?
Let me see if I can share this to you, which I know I said that I would do that.
It's
And
first
billion times. But
okay.
wait, but their unit, the vendor's unit phi may not be the standard's unit phi, right? The vendor's unit will be like, could be like 4 slices or something.
Exactly.
This is what do we mean by maximum stacked unit? Do you guys?
I totally understand. But if a person sells a phi that's a 64 lane, so it's 4 slices as one phi, right? They'll say you can stack one of them because that's what they're selling. Make sense?
Makes sense.
Yeah, so I think our definitions are still in terms of the standard, and they need to be in terms of whatever unit the vendor sells.
Exactly.
Yeah. So yeah, it's fine. But,
Again, let me give you guys a little bit history why we picked that one, because we've in last round when we were capturing some data, we find out people are basically adding ridiculous number of stacking to increase their beachfront density. Because as you can stack, basically you stack one more, it becomes twice, 3 times, 4 times. It's going to be more pressure on your 2 sides. One is on the number of layers that you need on the package, and number 2 on the reach. For example, the maximum distance between RX and TX now is going to get defined between the maximum stackable unit last RX and last TX. I think the reason that we want to keep maximum stackable unit is for 2 reasons. What's the maximum distance and how many layers that we need?
No, it's agreeable, but it's maximum of the vendor's units, not maximum of like a standard's units.
exactly. You're just very bow-centric and you're thinking, Shahab, it's fine to use this language and couple it with this explanation. But
What about putting layer and those as a parameter?
don't expect you can calculate package layers from that information. We need to explicitly call out how many package layers are needed and stuff. Yeah, you got that down there. So
Okay, yeah, that makes sense.
Okay, what's the better wording to write?
No, but stacking is right, but we have to sort of, when we define a unit, it's not a single slice. It's no longer a slice. A unit's bandwidth may vary across, the minimum consumption bandwidth may vary from vendor to vendor.
I agree.
So is there somewhere we have to capture what exactly is the minimum bandwidth what are the minimum increments in which you sell bandwidth, basically?
so we have a number of data lanes in line 22, right?
Yeah.
Exactly. This is the unit definition of the unit.
Right. So I could write that it's 16 if I'm defining a BOFI, I could say there's 16 data lanes
Correct.
and I can stack 4 units. Or I could say it's 64 data lanes and I can only stack 1 of those units. So I can do either. Right.
I'm not sure about the last one that you said, but the first one I agree with you.
No, so I could say it's 64 data lanes and I can only stack 1 of those units. Because the unit is physical GDS has 4 slices in it.
Exactly.
And UCIe is defined that way. So you never stack them. You can't. So, you know, they're good. You're gonna sell a unit that has 64 data lanes, always fixed as 32 transmit, 32 receive, and always maxed at units is 1. That's how this will always be filled out.
Correct.
With something like that. So, you know, so that's why I say we're spending a lot of time on this, but I understand your figure, and I think it's very bow-centric. It's only usable if a person sells a small, you know, slice and expects the end user to stack them.
Correct.
And most people won't do that, but it's okay to have that terminology.
I think it's no, Kevin, just to sort of in defense, this was we're adapting definitions developed for standards to definitions for implementations, and now the differences are coming through.
Right. I understand.
And yeah, I have seen basically people stacking, by the way. For example, in again, old format XSR, people do a lot of stacking.
Yeah, that's true. But again, I'm still trying to understand 34, 35, and 36. So first of all, is X dimension beachfront?
This is, yeah, we have to define that. You're right. The X dimension is going to be the beachfront.
Okay. And then, so line 34 is the beachfront of the die. That makes sense to me. And then where is the depth of the unit?
Depth of unit, we never, but basically it's going to come from this 35 and 36.
I don't want to do it that way. It's making it too hard for people. The 2 things people want to write down is 34 and then the corresponding depth of the unit. And then 35 and 36 are just some calculations. I don't think they're useful at all. They're useful for some comparison purposes, but no person who's implementing a PHY cares about lines 35 and 36. What they care about is what's the X and Y dimension of the physical GDS. And
I will tell you the problem of 34 then, especially in your case, if you want to go bidirectional. There are some PHYs that unidirectional. You guys TX and RX is combined, and we have some standards that their TX is much shorter than their RX, or vice versa. Then we're gonna get to the basically some kind of business of guessing and estimation on the TX or RX beachfront. But the 35, 36 is
okay. You're saying the beachfront has to be aligned, but so line 34 is TX or RX beachfront, and you're saying if you want to have a unit depth, it could be different in TX versus RX. That's your point.
Exactly.
Yeah, that is true. I agree.
But if we want, we can actually modify 34. 34 is one that I don't like it, but we can modify it to make it better. But for me, that was a kind of one of those numbers that I couldn't actually believe when I was reading the last table, because I was not sure it's a TX, it's RX, it's an average of those 2. I think we need to modify 34, but up to you guys.
34.
TX or RX. First of all, we say or, then people pick the minimum one.
Actually, that's the other question I had in my head. Even if the standards are unidirectional, how many people will, I mean, like, are they going to sell, like the macros are going to be one or the other, right? It'll either be a bidirectional macro or a unidirectional macro.
But what about case of the bidirectional? This green one is what we define, TX or RX uni beachfront. But now, for example, in let's pick, sorry, I'm picking the name, Kevin, Elion, then if the TX and RX is in one unit, it's hard actually to just say, okay, how much is the TX, how much is the RX? It's a
But do you
combined.
care as a buyer whether it's a TX beachfront or RX beachfront? You just care about what the size, how much area it's taking, right?
That's my comment. That's why 35, 36 is more meaningful compared to the 34 for me. That's why we added to this version.
No, I mean like 34 could be fixed by, instead of saying TX or RX beachfront, you just remove the word, three words TX or RX, and you're good. Macro beachfront per die.
I don't know.
It's just how much beachfront do you take? That's all you care about.
By macro, you mean units.
Unit, unit. Whatever your unit is. And in fact, this right
But
now
are
is
you talking about the single TX unit or talking about TX and RX unit?
there is no such thing. The buyer is going to get, the vendor is going to give you a unit which is going to have this many bytes this direction and this many bytes in the other direction. Could be
No,
symmetric, it could be asymmetric.
Okay, could be asymmetric, could be only
Could be
one.
asymmetric.
So it could
But-
be only one direction, could be only TX.
Correct. So we have to add that spec, right? Which is like what here we're defining a vendor's unit phi.
Okay.
You need to define, so the vendor's unit phi may be TX, RX, and most people that I've seen it always seem to do a symmetric phi for certain target bandwidth. Whether that's implemented Kevin style or whether that's implemented like, D-matrix style is orthogonal to, but then the macro you get is the symmetric macro, right?
Most die cases are symmetric, yeah.
Most of them, but I'm expecting the new one, it doesn't.
So I know we're over time. I would like to see unit depth as well as a line that we have in here. And then the amortized ones are just going to be those numbers divided by the number of data lanes, I guess. But when people buy a macro, they're looking at how much beachfront does it use and how far does it go into the right, how much area does it take, right?
Unit depth per die?
I think so. And then your unit divided by the number of data lanes is your amortized, including clock and stuff, right?
Correct.
And that
And
means you also, sorry, go ahead.
We should just to clarify, so the unit beachfront is X and the unit depth is Y. The corresponding,
Okay.
then the corresponding,
had the
you're gonna do that later. Okay, got it.
I added as a comment here.
Yep, yeah, I remember you did that.
If you don't mind, let's get to these two because they are related. Then 38 is how
Wait,
many?
Shab,
Yes.
just one quick thing. We want to capture the amount of bandwidth in each direction, right? Whether it's symmetric, asymmetric for the unit.
I think that becomes based on a calculation of the number of lanes, number of wires, the speed of data,
Okay.
and targeted the speed per data lane. I think the rest is going to be based on calculation. We don't want to just.
No, but you don't want to say like this is a symmetric unit phi or asymmetric unit phi?
We have it, I think, here. Unidirectional simplex, bidirectional simplex, duplex.
Oh, okay. These are all for the unit, right? Okay.
Correct.
All right.
Then the two things that is left there before we get into the famous latency one.
Yeah.
How many TX and RX can share one clocking blocks? That's the good number to have from my perspective.
Wait, can they, like, if somebody gives you two different macros, your two instances of macro can share the same clock?
No, from implementation, people care if the 4 units are sharing one clock or 8 units are sharing one clock.
Well, what is a clocking block? A forwarded clock mean or a PLO?
A PLO at the TX.
Oh, okay, I see.
Because internally you have
So
to
if-
draw
if-
reference to those PLL. That's why people care that how many
If-
reference they have to route to get to that IP.
So if 4 slices in your, or 4 stacks in your, I can't remember what your figure was. What do you call the things that go into the chip of those
For example, in every,
units? So
in
so if
every
you have 4 units stacked and all 4 of those share a common ref clock input, then that number would be 4 in this line, right?
the other way around. In the 1 unit TX, how many clocking do you need? Or if you're adding more units to the X dimension, you're right, even in Y dimension, correct, yes. If you're, how many, basically, sorry, I don't know how to say it because I don't want to say unit, but when we are basically putting these units, how many data lanes are sharing one PLN?
Okay. Okay.
And the last one is max stacked unit. I don't know if we should have it here or it's the same as 35, but
No, it's not. The
it's a
unit
good number.
depth is X, and if you can stack 4 units, then the total depth will be 4X.
Okay, then should we stop
I'm
at
okay.
40? And thanks for everyone inputs and sorry being overtime.
Yeah,
Thanks, man. Hey,
Thank you.
wait,
Thanks.
before everybody goes, next meeting, I will send out notice. Can we talk about just sort of working out a publishing schedule backwards? If we want to release this in February, when we have to do what?
sure.
Yeah.
Sounds good.
Sure, sure.
Thanks.
Thank you.
Thank you.
Right. Bye, everybody.
Thank you.